Morning. This is for my friends in Australia. I built them a R154 bellhousing, and this is a front or all-wheel drive flywheel system. Imagine what I ought to start with is to talk about the change in these starter holes is the only thing I have to make using different flywheels. And this is drilled to accept the 4G63 narrow block all-wheel drive flywheel, and it'll also work with a second generation block for the 4G63 with this extra hole. So bear with me here. 28.2 centimeters. This is an EVO. It's EVO 9. And this is all the way out to 29 centimeters. 29.2. Now, the clutches, even though they have different numbers from the manufacturer, don't seem to change that much. This is a Toyota disc. This came out of a Toyota truck with a 22R motor. It's a 9-inch disc. It fits right inside of the Mitsubishi flywheel, so plenty of room. This is a front-wheel drive. This is the all-wheel drive. They fit exactly the same. This is the pressure plate from the Mitsubishi. This is a front-wheel drive. As expected, it fits the front-wheel drive fine. It also fits the all-wheel drive fine. The same thing's true with the second generation. This Toyota disc fits right down into the second gen, and so does the pressure plate. So I don't see where the changes are. Now in the EVO, you had a pull style pressure plate, and in my bell housings I'll be changing that to the push style, and that's just from popular demand. But that, I just wanted to get that out of the way, that when you order a bell housing, you tell me whether you want all-wheel drive or front-wheel drive, and then I change the starter location to change the diameter of the flywheel, the ring gear. This is my little cut-in-half imitation motor. That's my crankshaft that I build up. That's all just for all the work I do on these all the time. But that's how I get my numbers. And let me do that over. This is my starter plate that I built. This is exactly the way it was with the 4G. And then I added in this lower skirt so that you could place that in before you put the bell housing on. The starter location is what's very important to me, because this hole dictates where the center of the flywheel is in relationship to the starter. So it's real important to have that in there. And then the next piece I did was to build a shim for the pilot bearing. And in this kit you will find the shim is just a small spacer that fits up inside the crankshaft. Now yours is going to go in a little tougher because it's more for it's more of a tighter fit. But this is where the pilot bearing for this system is going to go in. like I said, yours is going to go in a little tighter. I want to make sure that this shoulder is flush so that this doesn't protrude out and in any way impede how the flywheel is going to capture down on the crankshaft. Then in your flywheel, I open up the center to 30 millimeter so that you're sure to have enough space for the input shaft to go through that hole. These are around 28 millimeters, so it's a good clearance. Then, in this case, we're using the all-wheel drive flywheel. And I'm just going to put a couple bolts in there, just for now. You want to make sure and to torque everything to factory specs or better, depending on what you're dealing with. But now that's going to be your all-wheel drive flywheel system. Then I use the Toyota disc, and you'll notice that this end is raised up, and this end is flat. This side always goes to the flywheel, and the raised up side always goes back to the pressure plate. So I'm going to put that in there. That's a Toyota disc with the Mitsubishi pressure plate. Now, because this is designed to the OEM pressure plate, that means that anything that's built for the all-wheel drive car will also fit into this system. So if you get a double disc or some other wild arrangement, they'll fit. It's always important to stagger how you tighten these, because you can damage the disc or the springs in the diaphragm if you over torque one side. All you wind up doing is warping the spring. So you tighten it down nice. And so you have it tight. Now if we got our input shaft in right, it all comes right out. And now you got your complete package. Well, let's see. As for the throw-out bearing, I had to make this, and this was what made this all happen. This uses a standard first generation 4G63 Mitsubishi fork and pivot ball, and everything else is built into this system. Now this accepts a standard Toyota throw-out bearing from an '86 Toyota truck with a 22 RE engine. It's very standard stuff. You'll be supplied with the part number when you buy this kit, so you can buy a new one. But anyhow, you can see how this is worked in, is so that this fork fits down into that slot and doesn't retract too far, and yet it has freedom of movement so that it can work your clutch system. I put the imitation transmission on the bell housing just to show you how this is going to work. This pivot ball just simply goes into the proper hole, and then just gotta lay in your fork, slide it over your yoke, and it all snaps in place. And that's freedom of movement. You can see the teeter-totter out here. It's just as easy as pie. The only other thing I have to add to that is if you decided you wanted to change a clutch into something different, you could cut this land down just a little bit and position this bearing back further to afford a heavier clutch. Or you could shim it forward with some shims, either way, when you assemble things up. Now this does come together, so you don't have to assemble a thing. This whole system goes up on your engine and just snaps into place. You'll find the longer bolts are provided for the bottom. That's because I felt there was so much stress on those lower bolts, I wanted to make them as long as I could. Don't forget to take the time to chase the threads and make sure they're all clean, so that when you torque the bolts, you're actually torquing, you're twisting against the motion, or you're binding that material instead of binding in the hole. Something in there. These all come with the clutch kits that you need, the slave cylinders. And the other most important thing is that I shorten this shaft in the front. And I shorten it just down to the width of the pilot bearing. It comes out to be 10 to 12 millimeter extra length here. And I had one guy leave it long, and he broke the ear off the motor, so be careful with that. Make sure and shorten your input shaft to your R154 down to the width of the pilot bearing. Yeah, I can't reach it down. So this is your fork. This is the motion it's going to make. There's my input shaft. I got to move my crankshaft just a little bit. There. The problem with that short crank is I don't have the thrust bearings in it. But you can see I can move that fairly easy, so I know she's pretty centered up. Then I put my washer down in there. Bring that forward. Now these are laid out to have about 3/8 of an inch of throw. In the metric world, I think that's around 6 millimeters. Sound about right? No, more like, no, 8 millimeters, 5/16, so whatever. These bolts are all provided and the cylinders provided. This comes from a Toyota Celica Supra. I think it's an 85 to 88. And the reason that it's important to use this cylinder is because it's on the passenger side to stay away from the heat from the exhaust on the, it's on the driver's side, excuse me, to stay away from the heat of the exhaust on the 4G63. So the bleeder is placed on top. All the other Toyotas were on the passenger side, and that made it so that the bleeder was on the bottom. This way here, the bleeder's on the top. So now there's my fully packaged deal. That's a complete R154 Toyota transmission bolted to a 4G63 turbo motor, narrow block. It uses a standard starter that I found on everything. I have bought the front wheel drive, the all-wheel drive, and the Evo starter, and they all look to me to be exactly the same. There may be something inside, I don't know, but they sure don't act like it. And that starter plate, again, is what centers the starter to either the front wheel drive or the all-wheel drive. It takes a little longer bolt to use, which is alright. You will notice that there's another hole here too, just right in the center of that. And I make a small bracket that bolts to the side of the block that gives you an extra added strength bolt if you really have a high performance application that you want to deal with. So that way I can build in 6 bell housing bolts instead of just 4. And if you'd like to have that application, just get a hold of me and I'll work it out. Naturally, if you're going to show somebody something, it won't line up. And there it is. Let's see if I can take that out of there. You can see how it lines up and stuff. Them 2 lower bolts, I also make a bracket. I want to make an oil pan for that so that it'll bolt into the lower bolts and give added strength. But the starter all sits in there just as nice and easy as can be, just right where it should be. That's it.